This is chapter 14, Sound, problem 23. Two trains on separate tracks move towards one another. Train 1 has a speed of 130 kilometers an hour. Train 2 has a speed of 90 kilometers an hour. Train 2 blows its horn, emitting a frequency of 500 hertz. What is the frequency heard by the engineer on train 1? So, there are two trains. I'm just going to use ovals to depict these two trains, and train 1 is here, this is 2. Train 1 has a speed of 130 kilometers an hour, so we need to convert that to meters a second because these equations all work with the SI units. So 130 kilometers an hour is really 130,000 meters a second, or 130,000 meters per hour. So this is meters, and then it's in per hour right now, so if we divide that by the amount of seconds that are in an hour, which is 3,600, then we'll have meters a second. If you do that in any calculator, it comes out to about 36.1. So this one is moving to the right at 36.1 meters a second. And the other one is going in this direction towards train 1 at 90 kilometers an hour. If you do the same equation, or the same conversion, 90 kilometers is 90,000 meters per hour is 3,600 seconds, which equals 25 meters per second. Now, if you take the equation for the Doppler effect, it's the frequency of the sound heard by the observer is the frequency of the source. Oh, I forgot to include the horn. So, number 2 emits a frequency of 500 hertz from this horn. So I'll draw this horn. And the frequency of it is 500 hertz. So that's this, frequency of the source, times velocity of the it's the speed of sound, the current temperature, plus the velocity of the observer over velocity of the same v, the speed of sound, minus velocity of the source. Velocity of source in this case would be this velocity right here, which is 25 meters a second, and this one is 36.1. And for this equation, positive is set in the direction that they're moving towards each other. So both of these, for the purposes of this equation, are moving in positive direction, even though they're not moving in the same direction, like left or right. So if you plug it in, 500 hertz multiplied by, they assume that you think that you assume the speed of sound will be 345 in the book. So 345 meters a second plus velocity of the observer, which an observer is train 1, 36.1 meters a second, all over velocity of speed of sound, right here, same one as the top one, minus 25, which is the velocity of this. Put those in with those values in your calculator. It's comes out to 595 right there. 595 hertz.